Welcome back to another episode of Marcelina, my Reliance 44 sailboat refit update. Okay, so in the last episode, I covered some of the work I did on the companionway trim. Also covered reinstallation of the main winches and some other work. But most of the video was dedicated to the fabrication of a new rudder, in which I shaped the two halves from Douglas fir, designed the shaft components, and routed the slots where the stainless steel shaft parts will fit. In this video, we'll cover the rest of the rudder work from assembly to installation. So the fabricator finished making the parts made out of duplex 2205 stainless steel. The bottom support, as you see, is a welded flat plate to the bottom round section of the rudder that fits into a bronze support bracket. Now, before putting the two halves together, I still needed to route out the cavity for the bottom support. You also see that I moved work to my garage where I could at least put some heaters in it so it wasn't so cold during the winter months. The small diameter at the very end of the bottom support fits into a bearing which is also part of a bronze bracket that bolts to the bottom of the keel. Now in this part, aside from the loading of carrying the weight of the rudder itself, I figured the main force when the rudder is acting is going to be side loading. That's why I had the small round section welded to the steel plate to distribute that load within the rudder. The top support piece will also have some side loading, but the main force is going to be torsional. In other words, a twisting force translated from the steering mechanism, the quadrant above, down through the shaft and then into the rudder. So in this case I used radial welds around the diameter of the shaft such that the support pieces translated that force into the body of the rudder. So once the inserts were test fit, it was time to mix up some epoxy and mate the two rudder halves. So here I'm using the West System epoxy, as I have for the entire project. This is thickened with 406 colloidal silica filler. It's a good application for this filler since it's used for adhesive applications. I used a plastic trowel type tool to meter the epoxy onto the rudder half. I used a generous amount of epoxy in and around the steel support specifically. I wanted to make sure I filled all the gaps and that when the two halves were put together, some of the epoxy squeezed out. Working alone, I needed a way to carefully place the upper rudder half on top of the lower half. So what I did was repurposed a portable scaffold I had purchased, rigged up some ropes, lifted the one half into place, and then when everything was ready, I just wheeled it into position and lowered it onto the bottom half. Here a little more goop going in place around the top support piece before putting the top half in place. Then I applied a lot of clamps around the perimeter of the rudder to make sure that I squeezed out the epoxy and closed up all the gaps. The rudder halves had actually warped a bit from the low humidity during the winter, and I had to use some extra clamps to make sure that that gap closed up. Once the epoxy had set up, I used a 1/2-inch plywood, I'll call them caps, pieces put on the top and the bottom of the rudder, and then I routed the corners so that the fiberglass cloth wouldn't go over sharp edges. These caps were both epoxied in place and held with stainless steel screws. Then there was some additional fairing work done before laying up the fiberglass. Oh, and I had to expose part of the rudder shaft. There's a bronze bracket that actually goes around this part of the shaft and then bolts to the keel. This acts as a kind of a safety strap that keeps the rudder from falling out if the bottom bracket or bearing breaks. I started the fiberglass work and then realized that I hadn't double-checked the clearance between the front edge of the rudder and the back of the keel. And it turns out that I needed to shave down the front edge of the rudder. So what I ended up doing was I made little wooden donuts. You can see I slid it onto the shaft here to match the clearance between the rudder and the back of the keel. And then I used a string to ensure that I removed just the right amount of material from the front edge of the rudder. This technique also helped me ensure that the rudder shaft was perfectly aligned. Well, it wasn't perfect, but it was pretty close. Unfortunately, I didn't film the laying up of the fiberglass, but I can tell you that I used one layer of 1.5 ounce chopped strand mat and then a heavier layer of 1708, which is a combination of chopped strand mat and a biaxial heavy woven layer. Next came 4 coats of Total Boat's Total Protect 2-part epoxy primer. It has a very high solids content, so it's important to get all the sludge off the bottom and thoroughly mixed in. Now, I didn't use a peel ply on the fiberglass and epoxy layup, and the result was the texture of the 1708 was still evident as I put on the primer coat. So when applying the primer coat, I made sure I put it on plenty thick so I was able to sand down the peaks a bit to get it reasonably smooth. If I ever do this type of project again, I'm definitely going to be using peel ply. I finished with 2 coats of Total Boat's Spartan bottom paint. It's an ablative paint with a high copper content. In between the layers of primer and bottom paint, I worked on removing and preparing the bronze support/bearing that supports the rudder. It's held in place with 4 screws on each side. Once the screws were out, I cleaned up the support best I could. However, when removing the screws, one broke off. Then the removal tool broke off during the extraction attempt. Finally, I ended up drilling out what I could and then just retapping the whole thing. After getting the whole area cleaned up, I test fit the bracket. Finally, it was time to reinstall the new rudder. I recruited one son, one son-in-law, and one brother-in-law for the task. After digging a shallow trench, we brought the rudder in and set it on a jack at the bottom of the trench. We lined up the top of the shaft and jacked it into place. Your end is down. The jack didn't quite reach high enough, so we ended up having to support the rudder, fill in the hole, and then put the jack back on top of the filled-in hole to continue the process. My son-in-law described the rudder as a beast in a short video he took on his phone. I'd have to agree with that. Now, with that project behind me, I can focus on other preparations for launching the boat later this spring. More on that work in the next episode. Thanks for watching.